Hey guys, today we're looking at voltage, current voltage graphs, current and voltage graphs. This is the graph. We show the voltage on the x-axis and the current on the y-axis generally. Now we need to know how basically these graphs describe how these different components act when we increase the current or increase the voltage, and how if we increase one of them, what will happen to the other one. So the first one we need to know is the resistor. Now the resistor graph is a straight line from the origin like this. This shows it is a linear relationship. It is directly proportional because it comes from the origin. Now, because current and voltage are directly proportional, this tells us that it is an ohmic device. It follows Ohm's law. It's really important to know. We're going to be describing these other devices in components in terms of that as well. And because it follows Ohm's law, it does not heat up. If the resistor was to start heating up, it would not follow Ohm's law and would not follow this straight linear graph, and it wouldn't be directly proportional anymore. The other really useful thing you can determine from this graph is that because it goes in a straight line in this direction, in the negative, this tells us, because there's the same relationship between the current and voltage, that it means that you can rotate this resistor in any direction, either direction of current. So if we had a circuit that looked like this, we could put that resistor in either direction. So if we set an A and a B direction, we could take this out and plug it back in the opposite way round, and it wouldn't matter. So this one, we can have a resistor. This means you can put this in a circuit and it doesn't matter which direction it goes in. It will just describe it in the same way that it does here. It will work the same way. Now the next one we're going to look at is number 2, the filament bulb. Now filament bulb is very similar to the kind of bulbs that you find in houses and in cars, in car lights, the old style. Inside the bulb it would look something like this, and our bulb will go around like that, come down, and then these. And what actually happens is, as the current flows through, this section here, the filament, gets really hot. The current increases lots. It gets really hot, and then it allows it to emit light from the filament, glowing so brightly and heating up so much that it actually emits visible light. So in terms of its current voltage graph, it's got a slight curve to it this time. It's curved. So this tells us, because we've got a results on this side in this shape, it tells us that we can flip this filament bulb in either direction like we could for the resistor, and it will still work. However, we know, because it's not a non-linear relationship, it is not a straight line. Me spelling linear wrong. It is not a straight line. We know that this is a non-ohmic device because it doesn't follow Ohm's law, and that is because, as we spoke about before, because it gets hot. And if something gets hot equals no ohms. If this resistor, we can describe this filament bulb as a resistor because it resists the current's flow. It tells us that if it gets hot, it can't follow Ohm's law, because Ohm's law tells us that for a resistor to follow Ohm's law, it must not heat up. Hold up. This is a potato. This is the potato of good luck in your physics lessons. Now, if you were good enough to get this far, the Potato wishes you the best of luck in your lessons. Well done for getting this far. Comment on your Google Classroom lesson and assignment. Thanks, Mr. Potato. And our final device that we need to know about the current voltage graph for is a diode, or a DOD. If a diode is basically there to allow current to flow in one direction, but will stop it in the opposite direction. So if we had this going in the correct, if we had this set up in the correct direction, it would allow current to flow. If we flipped it round and reversed it, reverse it, to quote the eternal Blazing Squad, it will stop the current from flowing. So actually a diode current voltage graph looks a bit like this. If we increased the voltage, the current will not increase. Basically, this means that no matter how high you make that voltage go in the wrong direction, it won't allow current to flow because it stops it. That's the whole point of a resistor. But it will start now. If we're drawing the voltage current graph, it's quite important to have a look at how I draw it, because it helps, well, it certainly helps me explain to myself how it works. So as we increase the voltage, the current will increase very slightly, very slowly, and then when it hits what's known as the threshold value, the voltage will increase a tiny bit and the current will increase loads. So what this allows is current to flow really easily in the correct direction, but will be infinitely resistant in the opposite direction. So it won't allow current to flow this way, it will allow current to flow that way. The arrow helps us indicate that. So the main things to remember from today: a diode is this one here, looks like this. A filament bulb looks like this. And finally, your old favourite, the resistor, which is the only ohmic device here, looks like this one here. This is also known as a fixed resistor. The resistor is